Hey, what's going on? And this is another episode of Daily Math Reading with Khan Academy, two-step equations. I think I am just about, yeah, here we go. I usually start streaming this. And I think it's working. Making, yeah, I think it's working. All right, so basically this is going to be a video where I go ahead and go over, different math problems and stuff like that, all the way from basic arithmetic to algebra. So the idea is to go ahead and just, move through it really quickly, not too fast that you can't figure it out, but there is a way to kind of go back and look at these up in the future. So what I'm going to do right now is I'm just going to start out with two steps to equations. You should always go ahead and check out these particular videos, but I went ahead and I made a little explanation of like what the two steps equations is from the videos. As you can see that, when you have you have 3x, a variable multiplied by a coefficient or a number like this right here, you would want to go ahead and try to get it by itself if it has a number attached to it, like an addition number like this plus 2. And then when you get down to the bottom, you can either, when you get it, not to the bottom, but when you want to probably get it by itself somehow and move where you would have it will basically be x equals 12 over 3, which equals 4. And this this little description here was what was used in the video, right, roughly to address that. If you have to balance these out, this was like on like a scale of some sort, and they were on a scale. How would you get it to balance out? Well, you would do an equation like this to make sure that the amount that's on one side is on the other. That's what this equal sign is basically for. So now I can go ahead and let me. Oh, it doesn't let me get rid of all of it. All right, so let me go ahead and go to the video and get started. All right. Oh, I just realized something. I did not start. There we go. Yeah, so when I actually move from the different screen, it actually unpauses it, but that's great. I'll go ahead and go back to it really quick. So this is basically the two-step equation method, and there's a lot of things on the screen right now. I apologize about that. But it has, 3x plus 2 equals 14. You would first start solving this equation by getting 2 by itself by putting a negative 2 on both sides. Then you would end up with 3x equals 12 because this will cancel. And this 14 minus 2 will lead you to 12. Then with 3x on the other side, then you would go into the division cancellation where you would take the coefficients and cancel it by itself, giving you with x and 12 over 3. 12 over 3 is equal to 4. This is another equation where you can do the same exact thing, but this is without the actual visualization on the top. So we're gonna go ahead and just take these two. I think that's as far as we're gonna get today, and we'll be able to work on this later on. There's 7 questions. All right, so yeah, 41 equals 12d minus 7. And I was saying before, what we would do is that 41 is on this side, you have 12d minus 7 over here. Let's get this d to be a little bit closer. Okay, let me get this here. And what we're going to do first is that we're going to try to get this. You want to solve for d. That's the term. That's the way I was taught, and I kind of remember. We're going to solve for d. Getting d by itself. because this variable is actually the most, I guess it's not as, you don't, it varies very much. So you have to go ahead and figure out a way to putting it over to get rid of it. So we get rid of it by canceling 7 on this side and then adding 7 on this other side. You'll end up with 48. And then you have 12D here, right? Now, like I said before, now we will, I like this cancellation thing is weird. It's what I'm actually trying to figure out is what am I doing, right? It's like, well, we're trying to find out if we had 12 on either side, if we was able to solve for 12 on both sides, what would be the magic number that D would have to be in order for it to equal 848? So that's why we say 12 over 12, because this actually means when it says cancel out, it just becomes 1. It becomes 1D, and then on this side it has 48 over 12. Well, that's just 12 plus 12 plus 12, which is 48. And now that we have that, now we know that D equals 48. We know that D is actually doing that, And to me, I feel like this is a better way of talking about it and not removing a lot of these things as it goes along, because this is exactly what's happening. This is how the math would actually be if you were writing it in code. You would have to kind of find. I mean, you could probably avoid having the 1 there because it would solve it by itself. But suppose if you wanted to, explain that somehow, you would have to actually code that in. So let's go to here. So once we get to 48, we get to. I'm sorry, I actually put this actually wrong. It's 4. So it's 48. 48. Wait, no. Wait, I did this right. 12, 40, 48. Leave to 4. Right. And then that would be 4. And then if we go back to this, right, and we go back to this D4, it says this will be 48 minus 7 equals 41, right? So it would be 4. The next one is you have 11B plus 7 equals 40. And this is basically the same way we were doing before, where we would take this 7 and then we'll take, this will get canceled out. This becomes, when you cancel this out, this becomes 0. And then over here, we would just get 33, right? And then we would have a 11B plus 0 equals 33. Now we can go ahead and do not a division. Yeah, like a division. Like we would cancel these things out in this side, leaving it to be 1B. Making sure that 1B plus 0 equals 33. This 11 would also go on this side too, this positive 11. And what would happen would be that we would end up with 3, because we know 3 times 11 equals 33, right? So we have 3 equals 1B. Or just B equals 3. Wait, what did I do? 11, 33 equals 11 3 times. Oh, whoops, yeah. Negative. Yeah. These are the things you gotta pay attention to. This would be a positive 33, and this would be a negative 11. This would be a positive 11, but what happens is that when we plug the 3 back in, in order to get this b here, this b would have to be negative. That's tricky. Sometimes you gotta like make sure you're paying attention to the order of operations and stuff. So 42 equals -7 minus z3. I'm gonna put this little cross in there like that. Now with this, first we would want to do the distribution property where we would take 7 and 7 would go in here and 7 would go in here. So first what we'll do is we will seven times like that. Yeah, I think that works. That's fine. And then we will just put the 42 here. Then the next thing we would do is we would multiply this to get -21. And we could leave that right there. And then you have, okay, and then you have 42. And then now we have that. I hope that this, you can see that properly, but we're just going to continue. We have -21 minus -21 or plus +21 is 0. Then we have this -7 here. And then we have here 63, right? And then we would, I think we would do is we would put the -7 on the bottom. I think that's the mess. That was a mistake I made before. I was supposed to actually cancel it out with a -7, leaving a z by itself. It would still be a -z actually. But now we have -63, which would be 56, +56. And then we would actually have z here. And then what we would do is that we can actually test this out to see what would happen if we would put in 56 right here times 3, you know, working with the one that's up here. You would have 53, right? And then we would have 7, right, times that, which would leave us to 21, 35, 37. Wow, I feel like I'm going way off. Without, I just, yeah, let me just finish, let me work on that. 56 minus 3 would be 53. And then we would times 53. Then we would try 53 times -7, which would be, this would be 35, 36, 37. That'd be -371. And that goes way off though. Okay, so when I get to this piece right here, what I'm doing is I'm gonna just, you know, erase all of that. And let's make sure that we're doing this properly. So we have this -7 here. That's correct. We have a +21 because this is 7. Wait, oh, see, there we go. I forgot. This -7 leaves us with a +21, which would bring us to a negative here. Yeah, I felt like that was weird. So this would be a negative. Okay. And that would lead to that. Then you would have 1, and you have 21, and then, right, and we would have this -6 here. And then what we would do is we would take this -7 here, and this would leave us with, I feel like it's 7. It's 7. It's because it's going to be a positive z. Yeah. So that's a positive z. So that'll be z equals 3. So we put the 3 up here. 3 minus 3 would equal to 0. And then we would have 7 times 0 would be 0. I still feel like that's not right. If that was a positive, if that was a negative 3, that would go to negative 6. Yeah. So this would have to be a negative. So that would be a negative 3. And this would be, and it would go to a negative 6. And then, yeah, and then negative 7 times negative 6 is negative 42. So it would be, we have to pay attention to that. This is why I like checking, because checking allows me to make sure that I'm doing things right without, if you have a lot of multiple choice questions, how do you go about checking, right? And what will be the fastest way to get a good answer on the exam? So let's go ahead and just move forward. You have 24 equals 3n minus 5. Okay. And you would have 3 times n, which would be 3n, right? And then you have 3 times negative 5. 3 times negative 5 equals 24. And then that would be negative 15. And that would be 3n, right? And then we would also have 24. And then you would have 3 over 3n, which would be, this will have to be, sorry about that number there. So I had to, and you have n equals negative 5. And then that's basically 24. And we have 24 equals n equals negative 5. No, that looks weird. Now we have n equals, we have n, we solve for n by getting 3 on, we asked 3 on both sides. We can't do this. This doesn't even work sense, actually. I just noticed that. So what happens here is that we don't even do that. I apologize. We're going to put 15 on this side and put 15 on this side. And we're gonna go ahead, we're gonna cancel that out, and we're gonna add 15 on this side, which is gonna leave it with 939, and then we have 3n here. Now we do the 3n like this, 39 was 3. Let's do that. So 3 goes into 3 one time, 3 times 3 is 3, 3 goes into 3, goes into 9, 3 times 9 is 9, 0, right? So it's 13. We could take this 13 here and plug this 13 back in here, right? Which would leave us to 8. 8 times 3 is 24. Eight times 3 is 24, but it's actually this was 13. Yeah. Yeah, so yeah, that was basically what it is. Now, next thing is we have 7n minus 4 equals 31. And what happens is that, 7n minus 4 equals 31. We're going to do the same thing we're going to do before, which we're trying to get 4 by itself. We try to get n by itself. So we're going to say, I think it says solve for n. So what we do is this is the step 1. This will lead to 0 equals, this is like saying, you have the same here, that'll be 7, 8, 9, 10, 11, right? And then you have this 2 is 27. Then you have this 7n, and this is plus, it can be minus as well, it doesn't really matter. But now we have that. Then we have this 7, we're going to put in the bottom here. We're going to put 7 on the bottom here. 7, 9, 30, 31. I think we're going to run into something new today. Okay, so we have 27, right? We solve for 7 on this side. It's going to be n equals 27 over 7. That's interesting. Let me see something. 27 over 7. I'm using a calculator to see what, because that's actually 27 over 7 times 7 is 27. Okay. Then we have, yeah, 27 over 7 times 7 is equal to 27. I never really could see that. Okay, so that's great. And then we have minus 4. Ah, I see what I did. All right. This is actually adding. I knew that was getting really complicated. Okay. So you have 35, right? And then you have 35. It's n equals 35. Well, not really n equals 35. N equals 5. And then n equals 5. And now we can go ahead. We get to say n equals 35 right there. So 7 times 5 equals 35 minus 4 equals 31. It's great. So now we have negative 13 equals r over 9 plus 8. What we're going to do here is that we're going to look at this number and solve for r. I remember when I was saying this before that when we have r over 9 like this plus 1 over 8, I try to look at it like saying r over 9 plus 8 over 1, right? And then it's still, equals 13. And then I try to get, 9 on both sides, right? So that would mean that 1 will go on this side, 1 will go there, 9 will go here. 1 times 9 is 9, and 9 times 8 is 72. So then we would end up with this new expression, which would be like that. And this will actually can be n plus 72 over 9. Now, I think that we can go ahead. We can even have this n plus 72 over 9. And now we can get 9. Now we want to get, it's like as if we're saying, well, actually, do we do that with adding? I think we do. Because we said, I think we can do that. And then we have n plus 72. And then I think we do something where we can do the same thing on this side too. Right? Which is 9. Let me try this. I'm not necessarily too sure. Which will lead to 117 over 9. And now say n plus 72 over 9. And in order for that to actually happen, we would actually have to have like a 117 over minus 72 would be 45, which means n equals 45. And then what would be 117 over divided by 9 would be 13. Ooh, that looks like that kind of works. So because 117 over 9 is equal to 13. So that would mean that, yeah, that actually what means that that actually was the way to do it. I think. Let me see now, because now we have, if this is not n, this is r. Apologies. R equals 45, right? If 45 over 9 is equal to 5, right? You know, that's the whole thing. Like this number equals this. Like it's really hard, you know, to kind of like understand that because I don't know, for some reason, like it's hard to understand what 45/9 looks like. But it's great to see this. Let me make sure. This is going to have to be a negative in order for this to work. Or does it? In order for it to work, it needs to be a negative, I believe. Yeah. I'm sure it just has to be, right? No. And how do you get negative 35? Okay, so let me see what maybe I actually skipped. Oh, okay. My nose is running. Okay, so what we have here is negative 189 over 9. All right, so let's scratch that because that doesn't necessarily work at all. It looked like that was gonna work. I was like, that's not what it was. So let's go ahead and what they did first was that, yeah, they did what I was used to, what I was supposed to be doing yesterday, where you get 8 on both, subtract 8 from each side. Yeah, and then that would leave us with 0, and then this would be like 21. Yeah, and that would be negative 21, and then you have this would be equal r over 9. All right, let's just move on to the next one. This is actually what it was. So it's very weird when I'm looking at it. I feel like it's negative. Okay. All right, so let's move on to the next one. So we have here negative 4 minus w plus 1 equals negative 24. And you have negative 4 times w, and negative 4 plus what? LB here would be 4. And then we would have here would be equals negative 24. And what happens is that what we would do, we solve for that first, right, the distribution. And then after we do that, we get this. Then we will solve, we get w by itself. So this will get canceled out. This would be a positive, which would lead to 21, negative 21. I mean, negative 20. And then negative 20 equals, this would get canceled out. We put the 4 here, and then you put the 4 here, and then that would leave us with 5. And yeah, I think W would be equal 5. Yeah. So the ones I actually got wrong, I have to pay attention to. There's certain issues where the mathematical steps you have to remember in order to get it right. It's not very straightforward. Well, it is if I create the formula for it. But that's basically it for today. Just want to go ahead and talk a little bit about that particular thing. It's like when the last 2 questions I actually had, I think that when it was coming down to you looking at fractions, like I just start like I want to get the fraction into something that I understand. I need to remember that. And then, or maybe try to solve the question without the fraction. And then after I solve the question without the fraction, then put the fraction in it and then see what happens. That might be another idea too. Like, create like a function, like if you have like an addition function and you have like 2 plus 2 is 1, that's fine. But if you have like 5/9 plus 3/9, if you put those together, you want to make sure that you are getting them both to be the same denominator. You also want to make sure that you're canceling out if you need to, or factoring. So I would I try to pay attention to like how it looks, like how it would look on code, and like how what you would use. Like I would create a function that would actually get the greatest common factor. I would get the function that would get the least common factor. I would get a function that would uh, I think that some of the math would actually would be done programmatically, but it would be able to break things down to smaller steps, so that way you can, if there's a problem, if there's an error somewhere, you can go back to that error in the function. Oh yeah, there's an error in the canceling out function. If that kind of makes sense. This way, you're not paying attention to um, so many steps at once. And if you're not familiar with one step, you can always go back to the step that just right before you made the mistake, and you probably won't make that mistake anymore because you'll see it more. So that's basically it for today. Take care. See you guys tomorrow.